Tuesday, assuming that we're actually here. Right, I said Tuesday, right? I think it was Tuesday. Yeah, it was the 4-5 up to 5-1, in case you weren't here yesterday. Who wasn't here yesterday? You need one of these.
We had a quiz yesterday.
What's up?
We had a quiz yesterday.
Quiz yesterday? No.
Oh.
Everybody else got that? The 5-1, 5-2 handout? Right?
I don't have it.
Okay.
Recheck again.
If you were here yesterday, you got it.
I know, I'm so freaking lost in space right now.
Do I want to do this up here? No.
At least flights are super cheap.
What's that?
Are you serious?
Oh yeah, flights are so cheap. I got last minute flights to Vegas, it's $200.
Oh, flight.
Yeah.
Okay. Are they saying lights? I'm like,
Oh,
okay.
yeah.
So flights cheap, cruises are gonna be real cheap,
Yeah. That-
with the possibility of having to stay on the boat
yeah.
for 2
I
weeks.
literally got them yesterday.
That's
and
2
then
extra
tomorrow.
days.
Totally,
$200
awesome,
round trip.
with crackers. That's all we have left, crackers to eat. Let's do that.
Why don't they go fishing? They're in the ocean.
Makes sense. All right, so what we did yesterday, just get everybody back up to speed, and everybody that stayed home, hey, how you doing? Just trying to get a jump on everything? I understand. We did this systems of equations idea, right? I tried to equate it to, trying to solve a murder. I love this idea of just as much that you don't know, you need an equivalent amount of things, relationships, so you can figure them out. All right, so few of us. Can we all pay attention that's here? Would that be good? Yeah? Oh, come on.
Answer.
Yeah.
You were saying?
Hello.
Yeah, I do. Sorry, I'm just replying.
God damn it. Alright.
They're probably trying to find their phone and they're like, somebody has it, they keep declining calls. Get the police on me. You're probably on my iPhone right now.
All right.
Police on-
Next time it rings, I'll try to grab it faster. Okay, so if I have if I just had one relationship, that's an infinite number of things, right? So I have to be given one more piece of information to be able to figure out one specific answer, right? So I want to do an example like we did yesterday and then bring it into the algebraic method to solve this. So if I had, let me actually make something that works. Wouldn't that be nice? Let's see. Yeah. All right, I got you. Give me. Oh,
Someone's a big fan of yours.
what the hell? They keep like hanging up right when I'm about to answer.
You're like,
You sure you're not declining
nope.
it whenever you pick it
You
up?
sure you are?
Are you pressing any buttons?
It's an Android phone. It's just like mine. Let's see. So that's good. Now I forgot what I wanted to make. That's right. All right. Okay. So the way we did this yesterday was we graphed these two lines, and the answer was where the lines met. And it makes sense because when you graph a line that captures all the answers to that, and what's supposed to be the answer to the system of equations is anything that works in both.
Get it.
You can't just turn off the phone or,
Every time. I don't understand this. It's weird.
Maybe it's because it was out in the rain.
There must be a fan or something.
Yeah, it's really freaking out. I don't know. It can still get calls. I love that shit.
Break up with that.
That's not his phone.
on my phone.
Yeah, I know.
Thank you.
They didn't care about it, they don't care.
Now I could just leave it out in the rain. So let me kind of cut to the chase here a little bit. So I could solve this for y, and then I would know the slope and the y-intercept. And I could solve this for y and know the slope and the y-intercept. I can then solve them by seeing where they meet. Well, let's be a little smarter about this. I've got, so each equation, what sucks about each one is that there's too many unknowns in each one. Here, younger person, answer that. What am I doing wrong when you try to answer it?
Double tapping.
Hello? Hello? Hey, is this your phone? Oh, your girlfriend left her phone in a classroom. Are you calling me double time? Why is this going off again? Good morning. At Grossmont College, she left it in 100, 126. Are you there?
Oh no, it was on the ground outside.
On that ground outside. Are you still there? God, I feel like I'm old as hell. Am I old as hell? Hey, why is this still going off? This is driving me insane. So this phone is in 100, 126 at Grossmont. So she can come get it or somebody can come get it. Okay? I'm so happy this is on. All right. Thanks, man. I'm going to get back to teaching. Bye. That's a funky ass picture of you. All right. All right. Nobody else better call this damn phone. It's a normal day. That's all it is. All right. So, I kind of want to let's do this real quick, just because I want to.
Just turn it off.
How did you do that?
Out of sight, out of mind.
You should leave it in the rain.
There we go. Oh, I gotta unlock it to turn it off. Are you kidding me?
Oh, too bad you don't know the password.
All right, screw it. And I can't turn the sound down. Normally you could turn the sound down.
You should be able to turn it into silent mode on the side or something.
Nope. All right. So, coming back to here. If I solve this for y, I'm going to subtract x. And then I'm going to divide by 3. You guys finish that. Solve both of those for y.
Let's go.
Doesn't want to respond to me.
Can I see it?
Can you turn the
It
rain
has
off?
to be silent mode on that thing.
Yeah, thank you. All right, so if I solve this for y, divide by 3. Right. Right? Did you get it?
No, they hung up.
Thank you. Well, I mean, can you turn off, can you do anything more than I could? The answer has to be yes.
Yeah, probably.
Thanks for that. All right. I set myself up for that, it's okay.
Yes,
And
you
then if I
did.
solve this one, I get here. Cool, right? All right. So if I plot these two, and let me do this real quick. You guys, I'm pretty sure could do this on your own. What is it, 7? So if I do this one, 7, down 2, over 1, down 2, over 1. So we talked about this yesterday. When you do this, you want to do several, so you can really see where they meet. And then this guy starts at 2, goes down 1, over 3, so that's right there is where they meet. Okay. So you can imagine there's a couple of reasons why I can't always do this method. right? Sometimes they'll meet at some point like 1.7 comma 2.999. I'm not gonna get that from my picture, right? Now, I already know the answer is gonna be what? What's this?
3-1.
3, 1. And if we check it, 3 plus 3 times 1, 3 plus 3 is 6. 2 times 3 is 6 plus 1 is 7. Check, check. Okay, so that's true. So we needed an algebraic way to do this because, you know, I don't graph really well. So I'm not going to be able to catch anything that's not a whole number answer. So here is the algebraic way to do this. Do you see how this guy is much nicer than this guy? You guys agree with me? In general, this guy's got a fraction in it. Look at the information this one tells me. For this problem, I don't know what x or y are at all, but I do know y is this. Now stay with me. This second guy tells me that y is this.
Yeah.
So then,
I don't know about it.
in the first guy, I can rewrite this first guy using that information. So I want to use both pieces of information together. So if I rewrite, hopefully this part makes sense. More people.
Hooray!
Stay with me. This information came from this equation, yes?
Yeah.
I would never want to plug this back into itself. That's going to give me something like 7 equals 7. It doesn't help you. So I always want to plug something into the other one that I haven't used yet. So here's the problem. I have 2 unknowns, but this, when I write it like this, I know what y is.
Yes.
In terms of x. So how can I rewrite this first one now? It's going to be x plus 3 times y, but what's y?
Negative 2x plus 7.
Coolness equals 6. So I still have the same equation, x plus 3y equals 6. Yes.
Yeah.
And then what's better about this equation than any other? It only has,
It's in the classroom, you want me to take it to Washington, or can you be here in the next like 45 minutes?
yeah, in case you got here late, mystery phone that we found.
I
Person
take it to
calling.
admissions.
So you guys see there's only one variable?
You should not know where. Okay, can you tell her to come to the class? I'm in class, I'm not gonna walk it over to admissions. So you can come over to a classroom and on the portables, it's 100, 126.
Yes. Or they can say goodbye to the phone.
Yeah.
We will
It's a
sell it.
classroom, it's down right outside, so she should know where that is, it's 100, 126.
You got it? All right. I was gonna say, either say yes or just
That's the end of that.
leave us alone. All right. Thanks, Bruce. So now that I've done that, I can solve this guy for x. Right, so let's see. So just like we always have, it's gonna feel nice because we haven't had a just normal equation in a while. All right, keep going. What do you get? Negative 5x. Here, of course, I can just move that over. 6 minus 21.
Negative 15.
Negative 15. Divide by negative 5. I know that x is 3. Baby. So just like when I graph it, I have 2 pieces of information. Together, they get the answer. This is the algebraic. This is the first algebraic method we're looking at. And remarkably enough, it's called substitution. I figure out what one variable is in terms of the other one, and then I plug that information in. So I know that y is this, so wherever I see a y, I can replace it with this. And did they get any weird? I don't know. So what's the problem though? All right, you guys get the idea so far? No. Okay. Sorry. We're gonna do another problem. Even if you're quite not with me yet, what's wrong? Have I gotten the whole answer yet?
No.
Are you for a phone?
Yeah.
Okay.
Thank you.
amazing, they were giving you shit about coming to get it. Anyway, I know what x is, so I can figure out what y is. I just have to plug it back in. All right, so let me do a fresh one. Let's start over. All right, so say I'm given this system of equations here. What you got, Jeff? I like it. Now, we have a choice here. What's the easiest variable to solve for in either one of those? Why do I not want to solve for x?
Because it has a fair.
Because if I solve for x, I'm going to eventually make
Fraction.
fractions. I'm going to have to divide by 4, divide by 3. So obviously, y's are better, and which one of these is the best?
Y equals.
This guy, because all I got to do to solve for this guy is,
Subtract 3.
I think you might have said it right. Yeah, subtract 3x.
Okay.
So now from the second one, I know that y is negative 3x plus 11, right?
Oh, yeah.
So be with me. So we know that for a fact, because this problem's given to me. I know these two things are true. So I know that y is this.
Yes.
Now look back at the first equation. It says 4x minus y, but what is y?
Negative 3x plus 11.
Yeah. All right, so let me go back over this. So I was given these two lines. Now, in section 5.1, we would just graph them and see what the answer is. We'd see where they meet. Section 5.2, we're going to be doing something called substitution. So that means solve for one variable and then take that and plug it in the other equation. We're using one piece of information together with the other one. So in place of that y, I could put this, because this is y is this. Equals 3. So that equation's 4x minus y equals 3 equals 3. It's the same equation, I'm just using what I know about y. And then I can go ahead and solve for x, right? What happens here? Plus,
3x
Minus.
plus or minus 11 equals
I like it. And then of course, 7x, add 11, 14. X is
2.
2. Now, of course, you don't stop there because your answer has to have two parts to it, right? We got the x part. The beautiful thing about substitution is you're always going to have that one equation that's already solved for the other letter. I know what x is. I just got to plug it in to get what y is.
Yes, sir.
So y equals negative 3 times
2.
2 plus 11. Y equals negative 6 plus 11. So y is
5.
Negative
5. Positive. 11's bigger. It's positive. So as an answer, this is acceptable. What's an even better way to answer it considering what the answer is graphically? Graphically, the answer is a point. Yeah.
0.5.
2,
0.5.
5.
Alright.
Yes, sir.
So we solve this system of equations. The answer is a graphical idea, but we used pure algebra in the middle. I didn't have to graph anything. I like it.
Done.
So you guys do this one.
Yes.
Oh, I gotta come up with no. All right, let's see. Yeah. Yeah. No, Jeff. There. That one I made a little bit easier, hopefully you guys noticed that. You already know one of the variables. Oh, darn it. Well, let's see. How far along are you guys? Hold back for a second. To make this come out a little bit better. Right now it's gonna come out with really disgusting things. I had these switched around.
I was about to ask.
Yeah.
If they don't go together.
That's better, okay. So do you know what X is?
1.
2y.
You don't have a clue
Not beginning.
what number X is, but what do you know about X? I know that X is this. So anywhere in this problem that I see another X, I can replace it with what it is. It's 2y minus 1. This is why we call it substitution. I think of this as a very sneaky way of solving these. You're just going in and kind of like replacing something with something. It's like Invasion of the Body Snatchers. So I can rewrite the second one, 5y minus twice what?
2y minus 1.
Yeah, because x is 2y minus 1.
2y minus 1.
Yeah. Yeah, equals. So it's the same equation. I'm just replacing x with what I know it to be. So the problems I was doing earlier kind of sucked because they didn't have a variable by itself yet, but we just solved for a variable and then plug that into the other equation. Because now I have an equation that has only one unknown in it. So now you can solve this bad boy. So keep going. All right, negative 2 times 2, negative 4, negative 2 times negative 1 is positive 2. Yep.
Maybe 1y?
Yeah, 1y. And I can subtract 2, so y is
Yes.
3.
Yes.
So then x will be twice y, but now we know y is 3.
Is that right? Not to divide by 1? Because we got 1 or no?
Of course not, because what's
No.
1 times y?
1y.
This-
We got
yes.
1y, not to do divide.
No, no,
the
what's
same
1,
thing.
no. What's 1 times y? Y.
Y.
Yeah, so there's always an understood 1 there. Even if I divided by it, it's still there. Because what's 1 divided by 1?
Yes, still the
1,
same.
and you
I
might
got
drive
the
yourself
same.
insane, so don't do that.
I got the same, yes.
Partially my job. Yeah, so 6 minus 1, 5. So what's the answer?
X is 5 and y is
5, 3. I love it. So if you don't write it as a point, I'm not going to take points off, but you got to get both parts, both answers. I like it. All right, so now you guys look at this handout. Does everybody have this now? Is that when we start working on 5-1 was on one side, 5-2 is the other side? Go ahead and look at 5-2. Do the first couple there.
No, yeah.
You need that. Yeah.
I meant to staple these together, but here you go.
Thank you. Thank you.
Huh?
I have to
I
staple
got you.
these together, so there you go.
So you guys have that? So do the first couple problems in there, if you haven't already. If you have already, then try out number 3.
Is that yesterday's?
Yeah, yesterday we did that one side, and on the other side is 5-2. Yeah. Did you do it right?
I'm trying to say that.
Yeah. Just keep plugging in. Yeah. There you go. Kick ass. All right. All right. Yeah, you got it. Yeah, looks like you got the right idea. Let's see. There you go. Yeah, X was Y. Put that in place of that. Kick ass. Yeah, so you stopped here. Yeah, you're about to go
I
Y
still
is.
have- Yeah.
All right, all right.
I have a question. Did you do this yet? Yes, you did.
Not by test 2.
What do you mean not in test
By test 2, we had not learned this yet.
two? But angelfish and what?
I know, but by test 2, we didn't learn this process yet of 2 variables. That's what we're doing right now.
Oh.
Yeah.
So how was I supposed to answer this? Because I answered
The
it
way
as
we've
you
been doing it.
took it. My answer.
So here, the problem is you were assuming they had the same amount.
Yeah.
You said X of this and X of that, but how could that be true? If there's X of this
No,
kind,
that's why I crossed it out.
but then you didn't have any work shown.
I know.
I know, you just felt it out when I was using the line, so that's the problem. You gotta get some algebra. So here, this would have been perfect if you would have put there, if there's X of this fish, there must be 29 minus X of the other fish. Yeah.
I,
Yeah. All right. This first one's a little bit nicer because it's already solved for a variable, right? So in the second one, I know what y is. So I can use this in there. Yeah, like it. So I can rewrite this first one. I always number my equations so I can keep track of what the hell I'm working with at what time. It'll really come in handy when we get to the point where we have 3 of these bad boys. If I have 3 equations, how many letters are probably in them? 3. Yeah, there's 2 letters, 2 equations needed, 3 letters, 3 equations needed, so forth. So yes, I have done like 11. That's where it gets really exciting. So I can rewrite the first one using this information. So x plus 3 times y, but I know what y is. The biggest mistake people make is they leave out parts of the equation they're plugging stuff into. Just make sure that everything's still there. Bam. And then you can solve this, because it's all just x. Then you get x minus 15x. Negative 14x. You get 2. And so what do you get for y? So to. If you know that x is 2,
Negative.
yeah, just plug back in. Right. So I kind of think of it as dominoes. Once I know one letter, it kind of falls back and I can figure out the other letter. And again, I actually don't have to use this equation if I don't want to. I could put 2 in here, solve for y. It better be the same damn thing because it's supposed to be where these two meet. So if you put a 2 in the first one, so you subtract 2, 3y equals negative 30, divide by 3, I still get negative 10. It shouldn't matter which one because it's the point that's on both lines. So who cares which line you look at? They're going to agree. I keep making the same point over and over because I got a lot of you guys just looking at me, freaking me out. All right. So what's the actual answer? 2, negative 10. That would be the point where the lines met if I graphed each line. I would not want to graph these lines. Can you guys see if I solve this for y, I'm going to eventually have to divide by 3. And 3 does not go into 28. Do you guys see that? So my y-intercept on this line would be disgusting. So thank God there's an algebraic way to do it. Okay. Who's got number 2? What was the first step you had to do in number 2? Do you have an equation that has a letter solved already on number 2? No. Nope. So that's my first goal, is to try to figure out from what equation can I solve for a letter. So then I know information about that specific thing. So which one's obviously easier to solve for something? Second one, because this first one, anytime you have coefficients, you're going to create fractions when you try to solve for it. So I'm always looking for those variables that just have ones. And of course, this one, it's easier to solve for x. So if I add y, I know that x is 4 plus y. Or y plus 4, doesn't matter. So I know that's true. I know that x is 4 plus y. So if I see an x in the other equation, I can replace it with 4 plus y. Okay. So that's beautiful. I mean, it's correctly named and everything. Call it substitution method, because what are we doing? We're substituting x with 4 plus y, because that's what we know it is. So you can see how that's the same equation, 3 times x, but x is this, plus 2y equals 27, is the exact same equation. So it's sort of like if you said, if Tom's nickname was T-Bone, and you said me and T-Bone are going to the store, and then somebody's like, who the hell's T-Bone? Oh, yeah, that's Tom. I can just substitute T-Bone with Tom, because that's what that Tom equals T-Bone. So 3x, what the shit's x? Oh yeah, x is 4 plus y. Okay, so 3 times 4 plus y, it's the exact same idea. Yeah. Roughly, I just made that up right now, so hopefully that makes sense. And then I can solve this equation. Now I'm back in chapter 2. Just got to solve this equation for y. Yeah, distribute. So you get 12 plus 3y plus 2y, 12 plus 5y, subtract 12, and then divide by 5, y is 3, and then to get x, I've got an equation set up for that. That is the nice thing about substitution. You're always going to have that equation, just wait and know what y is, and then you know what x is. It's be 4 plus 3. 7. So then the answer is going to be 7, 3, 11. Something else you got to be careful about is put the point in the right order, right? X comma y. check it. 7 minus 3 is 4, check. 21 plus 6 is 27, check. Like it.